students, I am Pranjal from IIT Roorkee and I'll be your educator for today's lesson, where we will be going to study the very first chapter of class 9th physics, that is motion. So you have passed class 8th and I hope you must be aware of the term rest and motion. And according to you, rest might be when some object is not moving, when it is stationary, and motion is when it is moving. Okay, but this is a common definition that everybody knows, and since you are a science student, we should develop a scientific definition, and in this lesson we will be going to study that in detail. Okay, but before we start, I just want to ask you some question and put this in your brain, that you are living in your house for so many years and you have seen that it's not moving, obviously. So you will say that your house is at rest. Fine. And you come out of your house and you see a car moving on the road, and you will say that the car is in motion. But what if I say that your house is in motion and that car is at rest? Would you believe me? Of course not. But by the end of this lesson, I'll prove the statement right and I'll make sure that you'll understand the logic behind it. So let's start. So you can see the definition of rest and motion. Rest is a state of an object if it does not change its position with respect to the surrounding with the passage of time. And motion is completely opposite of it, if it changes its position with respect to surrounding and with the passage of time. Fine, I'll give you an example to understand more. See, you are living in your house, and here is a locality with other houses. So you wake up in the morning, you go out, and in your main entrance you see this house is at the same position. This house and every other house is at the same distance as it was day before, and this has been for so many years. No other house has come a bit closer or a bit farther from your house. So that means your house is at rest. Okay. Now, in the same way, you come out and in the main entrance you see a car. You see a car moving on the road. Suppose at time t equal to 0, or at some time, maybe at 9 a.m. this car was near this house. Now you see at 9:02 a.m. this car was near to this house, and then it left your locality. So this car was in motion. Fine. Now I just want to tell you one more thing. You know the earth is rotating as well as revolving. So if I am an astronaut and I am on this space station, so I'll see this earth rotating. So every other thing on this earth will be in motion according to me. So that means your house will be in motion. That car will also be in motion according to me. So how can this be true? You say that your house is at rest when you are here, and another person who is in space, he says your house is in motion. How can that be true? Confusing? Of course. So there is a term, there is a statement which says that rest and motion are relative. And this is very significant. Very few educators talk of it. And I am one of those. I'll share you the full logic behind it. Fine. So rest and motion are relative terms. It depends upon the frame of reference. And what is this frame of reference? You see a definition. It is a system of coordinate axes and all those things. I'll simplify this to you. Frame of reference is nothing but point of view. If somebody asks you, is this thing at rest or motion? You should ask this question according to whom you are asking. According to whom you want me to answer. If you want me to answer according to me, I'll tell you if it is at rest or motion. I'll give you an example. See, you are on a roadside and here's a car moving with a driver and other passengers in this direction, suppose. Fine. So if I ask you that do you see this car at rest or motion, you will say that this car is in motion. And if I ask the driver, are you at rest or in motion, he will say, I am at rest. So who is in motion? And if I ask the driver, do you see this person who believes that he is at rest and that car is in motion? If I ask this driver, this person is at rest or he's moving, what he will say? He will say that that person is in motion according to him. Because you have observed it, you must have observed this. If you are on a vehicle and you are moving in some direction, you must have observed every other thing going in the opposite direction, in the backward direction. You must have observed with the plant, with the trees and with the buildings. When you are crossing something, you are leaving behind other things, and that may seem to you that they are moving behind. But you logically know that you are in motion. But according to this is a natural perception that every other object thinks, every other human thinks that he is at rest and all other things around him is moving. That's why there was a theory long back that this earth is at the center and all other planets are revolving around it. Even the sun is revolving around it. Why we said so? Because every day we used to see sun rising in the east, setting up in the west. So we thought that sun is moving around us. This is because of the natural perception. Like I said, we all believe we are at rest. Then a scientist came with a theory that our earth is not at the center. It is the sun which is at the center, and our earth is revolving along with other planets around the sun. So in the same way, like I said, it is the natural perception that we are at rest. But in science, and when we talk of scientifically, every other thing in this universe is in motion. It depends upon whose point of view you are asking. So like I asked you in the earlier example, in the starting, I asked you two questions. That your house, I'll prove that your house is in motion, and I proved it through the astronaut. And I said that the moving car, the moving car that you see, you said it is in motion. I'll prove that it is at rest. Now I'll show you how. You see this car moving in front of your house at a speed of 20 km/h. Now if I ask you, you will say this is in motion. Now I come with my own car and just in front of this car, we are on the same side and going the same direction, and we are both at 20 km/h. Fine. Now if I see this, we know logically that we are in motion, but that I said perception. But if we perceive ourselves at rest, and if this person is moving in the same velocity and in the same direction, I'll see that this person is also at rest, because he is not changing his position with respect to surrounding. And surrounding is me, and with the passage of time, after 5 seconds you will see him here and I'll be also here. After then you will see him here, I'll be here. So he is not changing his position according to me. So what will I say? That person is at rest. So here I proved my statement that your house might be in motion and that car might be at rest. It all depends upon the point of view. And here comes the whole concept behind the frame of reference. So with this we introduce you to this chapter, and we will go on in detail of scalars and vectors, types of motions, uniform, non-uniform motion, Then we will come across speed, velocity, acceleration, equations of motion. There are so many wonderful things and very simple things to understand in this lesson. So we'll cover all those things in the upcoming lesson, and see you in the next video.